Hello, and welcome to my overview of the before, during, and after lesson plan. So this class is a fifth grade math class, and the unit is going to be geometry and measurement, and it is taught by yours truly, Miss Murphy. So the standards that I chose for this lesson is math um, 0.5.6a, which is recognize a cube with side length of 1 unit as a unit cube having 1 cubic unit of volume and the volume of a three-dimensional figure as the number of unit cubes needed to fill it with no gaps or overlaps if possible. And then also including math 0.5.6b, which is determine the volume of a rectangular prism with whole number side lengths in problems related to the number of layers times the number of unit cubes in the area of the base. So to simplify that a little bit, we have three objectives for the lesson, which is one, the learners will identify a cube as 1 unit of volume in three-dimensional figures. The learner will relate the process of finding the area of a two-dimensional shape with finding the volume of a three-dimensional shape. And finally, the learner will produce a blueprint of a three-dimensional structure composed of different rectangular prisms that they have calculated the volumes of. So the materials that we are going to need for this lesson is just pencil and graph paper for the students to use, unit block manipulatives, so those are like the little ones cubes, the tens lines, the hundreds like square, and the thousands block. And then finally, there will be a projector in which I project Minecraft from my laptop or computer onto the screen for the students to see. So the duration of the lesson is going to be about 45 minutes. And I'm just going to quickly read the overview of the lesson. So in today's class, students will be learning how to calculate the volume of rectangular prisms. We're going to begin by using Minecraft as an example to get the students thinking about how they can calculate the amount of blocks needed to create a large cube. Then we're going to move on to practicing examples of this by using the base 10 blocks and practicing the concept of layering them and how those create a volume. And then we will do some practice problems without the manipulatives and with the help of graph paper. And the students will have opportunities to present their learning after we complete the problems. And finally, we are going to review what we have learned during the class to get students thinking about how calculating volume is applicable in real life. So as for the lesson itself, the before section is going to be about 5 to 10 minutes. And the class is going to begin with Minecraft being on the screen. And I will have gone in ahead of time and created a giant solid cube made out of the individual blocks. And I'm going to start the class saying, like, who is familiar with Minecraft? Presumably most will be because it is very relevant in like pop culture today. But if some students aren't, I'm just going to give a quick synopsis. It's about how everything you build in Minecraft is used with a source block or a cube, and that you use that block to build everything and create everything. So I'll say, I built a giant cube for you guys. Does anyone think they can tell me how many blocks are in this cube? Or what do you think we have to do to find out how many blocks are in this cube? So after saying this, I can allow students some time to think and propose ideas, but I won't necessarily be saying, no, this is wrong or this is the right way to do it. It's just an opportunity for them to do a little bit of problem solving and think of it for themselves before I do the actual teaching. In which, after I give them that opportunity, I'm going to say, well, today we are going to learn how we can find the amount of blocks in not only this cube, but how we can do it in real life as well. And at the end, we're going to make blueprints that we can build together in Minecraft. So I just started here, read and present objectives in which I would like put on a slideshow and read off these three objectives that I previously mentioned to students. So for the during section of the lesson, this is going to start with me kind of making that connection between area and volume. So I'm going to give each table groups a handful of base 10 blocks. They'll only have like a couple of the little ones cubes, a couple of the tens. It'll mostly consist of the hundred squares and the thousands block. Um, so I'll review how we know the area of the hundreds. And I put 2D in quotations, but finding the area of that hundreds block is the 10 by 10 and multiplying those 10 little cubes by on one side and the 10 cubes on the other side to create that 100. So they know that from previous lessons. And then we'll go to how do we get from the 100 square to the thousands block. And then I can show the students how by stacking that 100 square on it 10 times is the same as having that thousands block. So after I establish this with the students, we can identify some vocab words, and our vocab words are going to be cube and volume. So in order to do that, I'm going to use the little ones cube as the physical example of how it represents a cubic unit. So the cube is going to be that little square. And then I'm going to connect that to volume, and how volume right here is the total amount of cubes measured in the cubic unit. So I'll show them the ones cube and the thousands block, and they'll see that the ones cube goes into this block 1,000 times. And like saying that maybe the ones cube is a centimeter, I can show how that ones cube is 1 centimeter cube. And because it goes into the volume 1,000 times, the volume of that cube is 1,000 centimeters cubed. Or 1,000 cubic units. So after we do that, I would assign each different table group a different 100s value. So that will be 400, 600, 700, anything under 1,000 that is a hundreds number. And I would have them create a rectangular prism of that value by stacking those 100s blocks. So for example, if I assign a group 400, they will show me that by stacking the 100s block on top of each other 4 times. So after they do that, I will call on each group or have a representative of each group share how they made that number and have them identify the volume in terms of cubic units. So again, if they have 400, they'll be like, this block stacked on top of each other 4 times creates 400 cubic units or 400 centimeters cubed. So through that like demonstration, I'll just connect the process of finding the volume of a 3D shape and how it's similar to finding the area, because they know 10 times 10 is 100 to create that square, and it just has an extra step of multiplication, which is times 4 to make 400. So that should take about 15 minutes, considering the students are already familiar with area and how that works. So then we will move on to the second half of the during section, which is that I will do some guided teaching. So I can demonstrate doing that on paper with varied side lengths, knowing that I have the board and the students are then copying it on the paper. We could do first, we find the area of the base and then multiply it by the height. And I'm going to be using non-multiples of 10 just so it gets students more used to those other numbers. So it can be an example of like 5 by 4 being the base and then it being 6 times high. They'll know to do 5 times 4 equals 20. And then if there's 6 layers of that base, then 20 times 6 is 120. So that would be 120 cubic units. So after I do a couple of those examples and we walk through it together, I'll have prepared 2 or 3 practice questions for the students to do on their own, give them a few minutes to work on that, and they can be using their graph paper as an assistive tool to help the visualization of each layer, along with they still have those base 10 block manipulatives. And after I give them time to do that, we can review. I thought I could choose some students to walk the class through the process they took answering each question, and I can stop and ask for questions or clarify some things. So after we do that, it's going to be the after section of the lesson, and we're just going to be doing a review of the main ideas. So some questions I thought to ask would be like, what units do we use when dealing with 3D shapes? And they'll be able to say cubic units. And why is it different from 2D shapes? And that's in the way that they have more than just the two dimensions. They're also like multiple dimensions in that sense. Or how are we using the area to find the volume? And why does it work like that? So finding the area of the base and then multiplying it by however many units high. And it works like that because the base acts like a layer. And then if you just stack the layer on top of each other, that's how you find the volume. And then after we do that, we can do some connection to the real world. Like here, I'd say obviously Minecraft is not the only situation where we have to find blocks and use blocks and find the volume of things. So I can be like, who are some people that need to measure the volume of objects in real life? And they can make that connection, maybe construction workers, etc., finding the weight of things. And then are there any objects in the classroom that you think we could find the volume of? So maybe if they see a box in the classroom or a solid bookshelf, they can point that out. But I mean, in reality, you can find the volume of anything, but we're just focusing on rectangular prisms. And I don't necessarily have an exit ticket, but I do have homework that will help connect them to the next class. And that would be that they can make a blueprint of a solid statue or structure that we can build. So if they make this blueprint, they can take the different components and find out how wide and how thick and how tall it's going to be. And then they can bring those pieces together and then find the volumes of each rectangular prism that they use, and then find the sum of the total volume. So in that sense, you'll know exactly how many materials / blocks you would need, like in Minecraft, because then I give the opportunity we can make those structures come to life in Minecraft through that blueprint they made. And this could go either way, where some districts have the educational Minecraft program that they provide to all students. But if not, I could also, having it on my own laptop, follow one student's directions and make that structure. And we can have like a little city that the students all look to and see that their work can come to life. So yes, this is the overview of my before, during, and after lesson plan. I hope you enjoyed. Thank you.